Today we're going to be talking about second derivatives. So we know that if we have y and we differentiate it with respect to x, we get dy by dx, and we call this the first derivative because we can differentiate dy by dx with respect to x again. So we get d by dx of dy by dx, and we normally write that as d2y by dx squared, and we call this the second derivative. We differentiate dy by dx in exactly the same way as we would any function. The rules don't change. So let's say we had y equal to x cubed plus 5x squared minus 3x plus 2. So dy by dx would be 3x squared plus 10x minus 3. And the second derivative, d2y by dx squared, is going to be, well, 2 times 3 is 6, x plus 10. And we can also write this y as f of x equals x cubed plus 5x squared minus 3x plus 2. And with this notation, it's f dashed of x is the derivative, so it's 3x squared plus 10x minus 3. And the second derivative this time is f, and we do a double dash of x for the second derivative, and that would be 6x plus 10. Let's look at a couple of examples. So given y equals 5 over 2x minus 3 cubed, find the 2y by dx squared. So first we're going to find dy by dx squared, and we're going to use the chain rule. So first let's make, I'll get rid of this just now because it's in the way. So y equals 5 over, 2x minus 3 to the minus 3. And here we're going to have u as 2x minus 3, so du by dx equals 2, and dy by du, so it's going to be 5 u to the minus 3. Dy by du is going to be minus 3 times 5, which will be minus 15 u to the minus 4. So dy by dx will be minus 15 over 2x minus 3 to the power 4 times 2, so that's minus 30 over 2x minus 3 to the power 4. But I'm going to keep it as this actually for the next part because it'll make it easier. So then the second derivative, we will again use the chain rule. So let's make u is going to be 2x minus 3 again, and y will be minus 30 u to the minus 4, dy by dx is still 2, dy by du is going to be 4 times 30, which is going to be, no, it's going to be positive 120, u to the minus 5. So our second derivative, the 2y by dx squared, will be 120, and now u is still 2x minus 3, minus 5, and then we times by 2, which will give us 240 over 2x minus 3 to the power 5. So you see that when we do the second derivative, we can still apply the chain rule. Everything is just the same as we would do for the first derivative. A curve has equation y equals x cubed plus 3x squared minus 9x plus 2. Find the range of values of x where dy by dx and d2y by dx squared are negative. And secondly, we're going to show that d2y by dx squared is not the same as dy by dx. Let's show this. So, first things first, we want to find the range of values where x is negative for the two derivatives, first and second derivative. So we have y equals x cubed plus 3x squared minus 9x plus 2. dy by dx is 3x plus 6x minus 9. Now when is this? When is dy by dx less than 0? So 3x plus 6x minus 9 less than 0, oh sorry, that's the squared. So we will factorise this. Firstly, we can divide through by 3 to make things a lot easier. Less than 0, so we'll factorise this. So x and x plus 3 minus 1. So we'll get x is going to be here minus 3, here 1, so x must be between minus 3 and 1. So now we're going to take the second derivative. So we'll take this and differentiate it again, so we'll get 6x plus 6. And when is this going to be less? When is the second derivative less than 0? So we'll solve again. 6x plus 6 less than 0. And that will be when 6x is less than minus 6, 6 is x will be less than minus 1. So we've got these two inequalities, 1 and 2. So let's draw on a number line. We have, so the highest number is 2, so we'll 1, sorry. 1, 2, 1, 0, minus 1, minus 2, minus 3, and we'll go down to minus 4. So we want to know what for both derivatives are negative. So for the first one, we have the range of values from here to here. And for the second derivative, it's less than -1. So from here and it goes on. So the what we're interested in is therefore -3 to -1. So x is between -1 and -3 is our answer to the first part. Now, the second part that we want to find out is dy by the second derivative is equal to 6x plus 6. But what is dy by dx squared? What does that mean? Well, that means we take the first derivative and we square it. So that would be 3x squared plus 6x minus 9 squared. That's what that means. And so we can see that they are not equal. This has got, well, it's going to have more than quadratics. This is that they're not equal. This is a linear function. So that does not equal 3x squared plus 6x minus 9 squared. So that's easy to show. So I hope this helps.